Okay, Sherwin, you're up.
Okay, good afternoon. Aluminum panel fabs by the whole Takeoff panel team. Oops. Okay, so architectural aluminum panels. Oops, wait, move that out of the. Architectural aluminum panels are a perfect complement to glass curtain walls. It can be formed to any shape, style, color to achieve the architect's vision. It's strong and durable to meet engineers' criteria. Aluminum panels can be plate or composite, solid or perforated, and painted any colors. We use it to design walls, soffit, columns, parapet, sunshade, or any other coverings. A brief overview of the panel process. We start with a thorough review of the panel scope, create a logical key sheet, modeling accurate parts and clear fab tickets, and it ends when we completely release the fabs to the PM. The main goal is to satisfy our customers, which includes the project manager, the panel vendors, paint contractors, and the field installers. The project manager wants everything complete, organized, and accurate. A wrong fab, wrong color, missed or damaged panels it takes like 2 months to reorder, which causes delays, waste of time, and waste of money. The panel vendors will need an accurate model of every part and fabrication tickets, so they can verify accuracy of every panel, less coordination, and it can eliminate defects. The paint contractor will need to know the group and sequence of painting. We had issues on panels painted on a different batch or different day, and coordination can avoid rework. The field installers will need an organized distribution or packaging. Constructability. Who's singing? Sorry. Constructability, will the panel work, and they need to know if the ease of its installation. All of this can be prevented, unnecessary movement and over processing. Okay, so panel scope is where we create a game plan for a new project. Our scope covers almost everything outside the curtain wall system. Anything that needs fabs and sent out to another vendor to fabricate. So our first we copy the latest set of shop drawings and highlight our scope. A good set of shop drawing is the best coordination. Here we decide what's needed. We differentiate if it's shop or field, stainless steel or aluminum, plate or composite. Because we want to know whose group is responsible, or so nothing is missed. We want to review the shop drawings. Are the panels properly elevated? Do we have parapet or soffit plans? What's missing? We want to check for constructability. Can it be fabricated? Can it be installed? We write a set of questions and discuss potential issues with the project manager. Propose a distribution or priority and how to decide about the panels when it is needed. Okay, so why distribution? Why do we need to break the panels into different releases? The distribution for a big job like Stevens Creek, for example, tells more about how to properly manage a project. So this is how we break it up. Priority 1 will be the typical ground floor panels, small break shape and wall panels, corner panels. Priority 2 is the soffit. Okay, they are flat and almost same sizes. More panels can fit into the pallets and they can be painted together for uniformity. Priority 3 are the parapet caps. Everything that goes to the roof are packaged together, and loaded on the roof. Priority 4 are the vertical fins, the sloping accent in front. This feature of the building is a different color than the rest of the building. We don't want we don't want the panel vendor to mix up the finishes. So this has to be its own. Priority 5 are the roof screen. We can set this aside until the roof is clear for installation. So this goes to be installed last. Okay, so how we do our key sheet, we want to include as much logic inside the mark number. So so for example, P30P01, the first letter is the type of material for yeah. So P is for aluminum, C for composite, and S we use for steel. Okay. 3, the next number is the order of priority 1 to 5. So this is priority 3. Okay, the letter P is the panel type. So it's a parapet panel in the standard library. And O1 is the series of panel, and it tells the sequence of installation. So for example, a field guy picked up a panel with mark number P30P01. He knows that it's an aluminum panel. It's part of the priority 3, which is at the roof. Okay, it's a parapet cap panel. It's the first one to get installed because it's 01. If you see where P30P02 is, then you can easily guess the sequence of installation. In this case, it's counterclockwise. So we hope this logic can help any field guide to do their jobs better. Okay, types of inventor model. There are 3 different types of modeling that we do. Fabrication tickets are created in Inventor. It can accurately represent our fabs that the vendors can study and use for their fabrication. There are 3 different types of inventor model. First is the part modeling. It's the basic sheet metal models. We use this for unique one-off parts. Next is the IPART modeling. These are intelligent parts that can create different configurations. We use this to create standard parts library that can be manipulated by data or spreadsheet. And the last is the frame generator. This is a great tool to create frame structures. We use this for assembling complicated structures such as this conical fin on Stevens Creek. Okay, this helps us to check if all the parts go together. This afternoon, we want to touch on IPART modeling in different ways of how we use IPARTs. So it can be used on typical panels that we can use a spreadsheet or logic into it, like the glazing panel, wall panels, soffit panels, and parapet caps. Okay, so to create a typical glaze-in panel fabs, our typical glaze-in panel is a pan with 1 inch return, 1 inch return all around, or it can take any size, shape, form, thickness, or miters. It's strong enough to attach clips and support box panels as well. So how can we turn this into a standard fab ticket? So I have an example here. So this is a typical P1A panel, okay? And we have, aside from the width and height return, we added parameters such as angle left, angle right, the depth of the panel, and the return. Okay, so on the job, we want to open the standard IPART and save it inside a folder. And then we want to update all this information for the project. Next, we want to open the P1A or standard IPART and save it inside the same folder. If we click the table here, so this needs all this information, part number, quantity, width and height, as well as the depth, return, angle left, and angle R to configure and create models for every panel. So this is a typical glass and panel order form. Okay, this usually is separated into like different types. So P1A is our typical 1-inch return. P1A 90L is a 90-degree corner on the left. So the panel needs a 45-degree miter on the left. P1A 90R, it needs a 45-degree miter on the right. P1A 270R is 273 inside corner. So we need a 135-degree miter on the right. So first we combine all the information together in one spreadsheet right here. And looking at Inventor, this table, we want to mimic that inside our, right here. Okay, so this basic formula from Excel, we want to copy that down. So it will grab all this information and arrange it so we can use it. We want to add the distribution and paste it right there. And then for the first 5 panels, okay, it will be a typical 1-inch depth, 1-inch return, 90-degree on the left and 90-degree on the right. Okay. For the other panels, we want to test if how the IPART can move or configure with different data. So we have the depth of 1¼ here, a return of 1½, 45-degree on the left, 45-degree on the right, 135 degrees. So all I have to do is copy this information, go to my IPART. I need to insert exactly the same number of rows, paste this information, hit OK, OK. As soon as I insert the data, I'll go ahead on my table and I can see all the marked numbers of the panels right here. So I can click to any panel and it can configure itself depending on the size of the panel. Okay. So there's the 45-degree left with the thicker return right there. And then this is the 135-degree on the right there. Okay. If I need an individual model of this part, I can select everything, right click, and generate file. So what it'll do is it'll create all 10 different variations of this part. So if I go to here on my ticket, it automatically lists all the information here. Okay, so I need a fab ticket for only the first 5 panels, which are the typical. So I can hit visibility, and this is my first ticket. Okay, if I want to create a fab ticket with the 45-degree miter, for example, I can hit this part, create model space, and then look for that panel. So that's P1A 90 left. Okay, and then it will automatically select that panel. I can click here, change visibility, and then only show this one. And then I can just adjust all my dimensions and then save this as another panel. So that's how we do glazed-in panels. This is quick and easy, but the hard part is once we're done, we have to spend days to back check our work before we send it out to the vendor. Okay, any questions? Okay, the next part of Okay, the next part of our presentation is the typical wall panel fabs by Daniel. Daniel, do you want to share your screen?
Yeah. All right, hello everyone. My name is Daniel Yepes, and I will be showing you how to create aluminum panel fab tickets using IPARTs on typical wall panels. So for example, this is Brocco Garage. As you can see, there's hundreds of panels all around the building. We wanted to come up with the process to be easy to check, easy to fabricate. So I will show you an example. This is a flat wall in Brocco. As you can see, there's many part numbers. P10B-01 is the first panel that will be installed. Going up, it will change 01, 02. The B means it's the B-type panel. As you go to the right, we'll change type. We have the P11A, which is the flat type A panel. If you keep going to the right, we have a C type with 3 faces. So B, 2 faces, A, flat, C, 3 faces. They all have a typical 1-inch return all around. And I will show you how to incorporate these data in an Excel template. So I will show you a video. All right, so this right here is the template. We have the data. I will show you for the panel B type panel, 2 faces. So as you can see, part number, total quantity. With 1, I'm showing you on the fab ticket. With 2, we have the height, the elevation, and then all the floors, 1 to the first floor to the roof. And then as we fill up this information on the right-hand side, I have it set up automatically to be filled up on the left side. So what we want to do is copy this information and directly paste it on the IPART in Inventor. So we go ahead and open the Inventor part. And right here, we want to open the table, as Sherwin showed you a while ago. We want to paste it here. And we want this table to look exactly as the Excel form to be pasted correctly. And then we go ahead and press OK. So as you can see right now on the left-hand side, if we click the arrow, there's the 3 panels that we created from the Excel form. So as you click them, you can see how it changes. P10B-01, P10B-02, P10B-03. And then so what we want to do is now create the actual part, a 3D model. So we want to highlight, right click, generate the files. We want to save the parts. And then what we just did, this is gonna create a folder inside your working folder. It's gonna be the type B panel that we're working on right now. So when you click it, there's your parts, 3D model. These are the parts that we send to the PM, and the PM will send to the vendor. And this is the fab ticket. This is how it's gonna look when you put the information in the table. This is the table that is gonna be showing on the fab ticket. This is your B-type panel. And as you can see, the right-hand bottom, that's for your project. You just fill it up depending on the project that you're working on, the thickness of the panel, the author, which is me, I did the panel, paint finish, project manager, and project coordinator. And that's pretty much it. We pass it back to Sherwin.
Any questions?
You guys have any questions right now on this part? I can answer for you guys.
Well, I think Ron had one asking about the P for the second phrase, but did it answer that question for you, Ron?
Yeah, enough.
Okay, so Oh. Can you see my screen?
Yep.
Yeah, it's the Excel. There you go.
Oh, okay, okay. Sorry. Okay, so next on our list is Andrew will share you how we create iParts for the soffit and the ticket, the fab ticket. Oops. Oops. Sorry. From this slide. Sorry, technical difficulties.
So as Sherwin was saying, I'm going to be presenting here the how we make parts. So we want to use typical parts that we have, as Daniel showed you and Sherwin showed you, with our glazed in and wall panels. But sometimes we get tricky panels that don't have a specific particular profile for us that we can use. So for example, here we have Stevens Creek, where the panel is very unique and it has that nice curve. So here we're setting up our panels to have the IPART drive when we want, no matter what size or shape or length the panel is. And so here, what we're drawing on the sketch is our parameters that are going to be used in the table to drive all the different sides that we'll take on with that strip of soffit. Is the music not playing? No. So when we're setting up our sketch, it's very important to know which side that you saw is being used. For a soffit panel or a vertical panel, we typically use the top view. For a horizontal panel, or sometimes, depending on how simple your soffit is, you can use the side view, left or right side view. And here Jared used the top view so that we can, because our shape is more unique rather than our flanges and return legs. When he finished his sketch, he made sure that his panels were his sketch was constrained, which is very important, because when we build the panels and when we add other parameters, if it's not fully constrained, it may blow up the other dimensions, and that's not good. That won't help us for when we're making iParts. It won't allow the panels to build themselves properly. They'll end up all having issues. So constraining them is very crucial. Labeling all of your flanges and your widths and adding the proper lengths is also very important. So once all these features have been completed, we then go to the creating an iPart, which will resume once he's done building the panel here. So because the sides vary a lot in terms of length and angle, he is constraining the return legs to keep with the width 1 and width 2 so that they don't overextend or undershoot, which is a smart move so that you don't have to worry about excessive modeling while you're making an iPart. So here, as Daniel and Sherwin said, we're now making sure that our IPART table matches exactly what our Excel data table shows. And in doing so, he's adding all the proper columns to match what is going to get copied over from Excel. Adding the exact amount of rows to match the Excel file so that all the parts get made correctly. And then, as you see, now all the parts are made.
Hmm.
And so each one then adjusts itself based on the parameters that were added. And that's how you make, that's kind of how we go about making a unique IPART. And then now here's my video on making a fab ticket for the IPARTs using Inventor. So first things first, we grab our typical fab ticket, and then we set up our project table so that we have all the correct information for the building, the PM, the author, the PC, the finish, the detail where it can be found, the mark number, the thickness of the panel. It just as Daniel stated earlier. And from there, we then add all of our views and ISOs that are crucial for the vendor so that they can size, so they can get the information that's needed for fabricating the panel. And then labeling each view correctly so that when they're, you know, holding it, they know exactly which side they're looking at. So using sketches, blow-ups, blow-up details, and allow it to show more clearly in terms of what the return leg is supposed to be doing. Because as you can see, if we try to extrude that whole right side view, it's going to be all warped and wonky. So this allows us to just show them what it may look like from one end to the other with the angles, so that they can measure. The vendor can measure what is needed for the panel. There are multiple ways of making this IPART. This was one way to just kind of show what the table has and what it drives. So it kind of varies per ticket. I mean, per part, like for what is needed. Here we're just showing all the different dimensions of what it could look like, what each side might look like, and where it's being called out from that data table, which you'll see shortly. So now I'm matching the table that we have from our Excel, which spits out all this information. And we turn off what we don't need, keep what we want, and then just keep doing a file save as for the next one, and so on and so forth as the panels go. You know, sometimes you get some dimensions that bust because the sizes change a little bit. It's just a simple adjustment versus having to redraw the whole thing all over again. But it saves a lot of time being able to use an IPART for your fab ticket, because you don't have to try and make a brand new fab ticket for every part again over and over. Instead we save a lot more time just saving as, and you know, just the information keeping up to itself. And that's kind of how we do an IPART fab ticket.
Thanks, Andrew. Okay. Next is how to use our IPART model and create an assembly of models. So I have another video here. Modeling the portal panels using Inventor IPART and data from the Takeoff. So the end result should look like this. From the Takeoff program, we got this data on green, but it only represents like the vertical or horizontal straight cut panels. So to create the IPART, we want an IPART to be dynamic and to show and give us like miters. Okay, so what we did first is added a couple more rows that will represent 1L and 1R. So that's 1L, 1R. Okay, and then added two more columns, angle left and angle right. Okay, so the typical ones will just have 90s, but the 1L will have 45 on the left and 90 on the right. And then the 1R will have 90 on the left and 45-degree miter on the right, which is this one. Okay. And then we go ahead and create our IPART with the data coming from here. So that's height 1, height 2, height 3, angle 1, and angle 2 right here. Okay. After that, we want to dictate the cut, which is the length, which is the width, angle left, and angle R right here. Okay, so we extrude, create our IPART, go to the table, and then this should exactly mimic what's here. So we copy this data to here, okay, hit OK, and then that will give us one IPART with different configurations. There's my one left, and then there's my 1R. Okay, and then I do the same for these vertical panels. And that shows here with 1, with 2, with 3. And then this dictates the height, angle left, and then angle R right there. Okay. So now I go to my assembly, and then I want to insert all the parts in. So I go place, E, which is the head part, open, and then it will give me a table with all these parts available. So I want to insert the typical one, 1L, 1R, okay. And then I want to insert the jump part. This one, open, go to my table. I want this one first, which is the right side of the portal. 29 is the left side. 30 is the left side. 33 is this side. And then I'll go to my 1L. And then my 1R. There you go. Dismiss. And then I just assemble them together, and that's my portal. Thank you. Okay, so any questions? Nothing? Okay.
I see Yana raising her hand. Go ahead, Yana. You're muted, I think.
Sorry. I noticed that you are modifying the order form. What I give you a lot looks like it's a lot of manual entry, and you doing the whole new thing out of it. Did you guys consider it maybe animated it a little bit? Is it just one of the things you're thinking about?
Um, our order form has so many, they have a lot of columns embedded and hidden, right, Yana? So we don't want to mess around with the ticket, but we can make it work for our end. Okay, so it's easier for us to modify it on our end because things keep on changing. So at least we can adjust to whatever changes needed. So,
Yeah, I think she's asking if there's a way you can automate it to where you don't have to do as much manual entry on your end. If you can get maybe Zach to help you come up with a way to download the information from the takeoffs that you get, so it automatically populates your release with the information you need. I think that's what she's asking.
Yeah, thank you, Ron.
Yeah. So for now it works. We have a way to, we have an Excel form that we can just copy and automatically it gives us that data. But we want more. We want to control the information. At least we know what we're getting. So for now it's okay. Yeah.
And I do feel like if we try to automate it, we'd have to use Revit once, Takeoff is done with it, which would then kind of make it a little more difficult. We'd have to reprint and make sure that the model that's there is actually correct. So, and that's not always the case.
And that brings us to our future state. Andrew.
Oh, right. So I thought you wanted me to share my screen.
Oh, sorry. Share your screen.
You're muted, Andrew.
There we go. Sorry about that. I had myself muted. So we're working on Matilda Commons Building A. Juan and I are actually using a live Revit model to build all the panels that are on this building, so that when it gets exported and when it gets printed, we also have a lot more information or data that we can use to allow our panel team to have a little bit of a faster process for producing these panels for production. So as you can see here, we have the model. Right now, Juan and I have completed we've completed the parapet caps for the most part. They're all ready for takeoff program that Zach's made for our panel process. We've worked on the guardrails. They're finishing the soffits right now, and then what we have next pretty much is just the eyebrow, which is kind of like our trickier topic. As you can see, it's not a simple little design here, so we have to try and figure that out. But the bulk of our work is really like designing these joints and making sure they work properly per our standards and panel team, so that whoever gets this building, all they have to worry about is worrying about the connections and how the panel terminates into the building, and all the sizes and whatnot can be extruded from the Revit model. And here we have Juan and I have made a lot of sheets, so like a lot of the times we don't have reflective soffit plans, or they're not as detailed for us. So we've been able to make these as part of the shop drawing set so that we can better build our panels and make it easier for getting them going. And then here we have, this is for the eyebrow area. This is another eyebrow. And here's a parapet plan blob. All the blue lines that you see don't show up on the shop drawings, but this is kind of like us setting up what it looks like. That's our reference lines that we use to kind of get the dimensions going. And then here we have kind of an example for our door portal. We're with our experiment, Zach's helping us print these mark numbers based on us building the panels, getting the right sizes going. We made details for panels that we feel is necessary and whatnot. But this is kind of our future state, just adding a lot more views and plan views, elevations, blow up details and everything like that to kind of help improve the process that the panel team is currently working through, and kind of working more in the front line of design so that we don't have to try and figure this out once the building is supposed to be ready for panel production.
You're doing these views yourself? The drafting team's not doing them?
Juan and I are both working on them right now.
So I mean, it's like the
For this
future state.
building.
Would you be doing them yourself on every job, or would the drafting team be supplying this information from the model for you?
So from what we're gathering, this process would then be done by one panel team member on the building. And if the drafter aid is needed, then I'm assuming they would probably assign a resource. But for the most part, what Steve wants is that we would take charge of this ourselves so that it's ready for us to then push it to fab tickets, and then our fab process is a lot quicker. Does anybody have any questions? No. But yeah, that's kind of our future state at the moment. We're just experimenting with how Juan and I can get a building done, kind of just while he was showing me all the drafting techniques that we have to edit the Revit models for panels to fit along with the architect's model and everything like that. Yeah.
So kind of a follow-up question. Earlier in the presentation, Sherwin had pointed out that there was a panel type A, B, and C. Is the future goal also going to have some standard naming for the way that panels are built and developed, so that each time that panel type comes into any building, you're always using those same guidelines, and then the panel itself would just be adjusted with the parameters of the width and height to fit the specific conditions?
You're right, Bill. So the idea is, Inventor and Revit is two separate, programs that doesn't really like to talk to each other. So the idea is Zach created, added something on the Takeoff program so that it can read data from Revit to Inventor. So yes, you're right. We will have like standard panel types that will be coming out of the Takeoff program that will tell us like the width and size and the panel types for the panel. And then the idea is if we have like the standard IPARTs tickets in Inventor, that the Takeoff program can eventually automatically create all these parts for us, all the fab tickets.
And to kind of add to what Sherwin was saying is that and answer a little bit on what you were saying, Bill, is the Revit families that get built, as long as we add the correct parameters in terms of making a P30B01, that is all something that we can add into the model and the Revit family itself, so that when it goes through Zach's program, it'll spin out the mark numbers based off the parameters that we set.
I have a quick question. Are you planning to use your own Takeoff program for this collecting information, or you're going to be continuing on the job Takeoff program?
From what we saw with the Matilda project, we are using the actual Takeoff program that's in the job.
So it's the first time you're doing it, and it is the job. Okay.
Yeah, I don't know if we are gonna end up making our own or not. But I feel like it would kind of all go to the same one.
Mhm.
Yeah.
I think Zach wants everything in one Takeoff program for one job,
Database.
one database.
But we would only need the database once we're ready to UPD all our panels. So we can just work on the Revit model to build everything for the building and then UPD our panels. And that's really all when we would need it.
Look at you, UPD.
Exciting stuff
That's
coming
pretty
up soon.
cool.
Sure.
Yeah. We did a little trial run with the door portals. I think it was a week or two ago with Zach. So, and it looked pretty good. We just need to add more parameters like Bill was saying so that we have the correct data. It was just a test run. So yeah, that's pretty much it on our future state. It's really just kind of going through these and making sure we have information for when we get to fab tickets. We could back check our work and whatnot.
Any more questions?
I'll go ahead and stop sharing.
That's it.
Saul, can I be part of the panel team? Are you hiring guys?
Oh, I like me too. It looks so much fun.
And then Juan has a larger
Want to
question.
learn too?
There's more to the entire post process and steps. Revit has a lot of parameters, and with Zach's program, it can generate a lot of information for them to be passed on to the panel team for fabs. We will make a doc or SWIS later.
Yeah, to kind of go off what he's saying is like we can use this scheduling tool that's here in Revit to kind of have it take control. Here we go. So we can add like a category of and double check our panels and whatnot, and also they'll use the Takeoff browser to kind of make sure all of our sizes and faces and anything that's weird to show up. So that's kind of alluding to what he was talking about, that there's a lot of steps that go into setting up these panels and making sure that they're right and they have the right information. That will then come later on towards the Swiss side, like that he was saying, once we get more into the nitty gritty of the details.
Okay.
But yeah, it's pretty much it for panel team, I think.
Yeah. So yeah, good afternoon and
Can I add one thing?
sure, Yana.
So right now, the part of our process for the panels, for the glazed-in panels, can I share my screen really quick?
Sure.
And it's more like a future state. So Sherwin gives me information how he wants to name them if we need to override the automatic names. So this is how it looks right now. It's only for the job what needed. This is example from Underwood. And the future state, hopefully, can you guys let me access to your Revit really quick to what you have? Oh, actually, I guess I can show to you here.
I was gonna say, did you want to just take control of my screen?
No, I'll show to you. I have a model open here. In the future state, we added feature for the panels, for the glass panels. Like let's pretend this is the panel. This is actually glass, but it's let's pretend it's a panel. So all this naming, if we need to override them, so we can go to, we have a profile modifiers now in the glass, in the panels. So we can override the name what we want right here. I don't know actually if this is actually the current, because we do have it updated, but I should have had Underwood open. Underwood would have it. But basically in the future, the hope is you don't need to go through this and give it to me in PDF and me translating it and possibly making a mistake. So in the future state, you can go on the model and name it any way you want for the glazed in panels. So they will be named the way you want on the units.
Right, Anna. So yeah, future state is any one of us can go into Revit and modify it ourselves.
Yeah.
Yeah. So once I'm done training with Revit, I'm going to show the guys. So we'll all be Revit masters. That's the future.
Okay, so thank you.
Thank you, guys.
Good afternoon. Bye.
Thank you,
Thank
guys.
you.
Thank you, panel team.
It's a great job, guys.
You.
Thank
Thanks,
you.
guys.
You dazzled us. You dazzled us. We want to do it now.
That was cool. Thanks,
Thank you, guys.